and I do record all the lectures, and then I do put them on YouTube because that's what I know how to do. I don't know how to put them on the Blackboard part, but my students, and sorry, I have to figure out the directionality of this. And so, yeah, the syllabus I did post, I think yesterday. And there's a couple things I just want to point out, and I would ask if you can look it over, and if you have questions, just come early on Thursday, or if you can stay after and ask the questions. And also if you can come early on Tuesday or Thursday this week or next week, and even just introduce yourself. One of the things is I mentioned, so you have an assignment due every class after today, so every Tuesday and every Thursday, and there we go. You're going to have to, because this is chemistry, we're going to be doing a lot of math and stuff. So like our first assignment is a study set, and I'll talk about that in a moment. But if you can print it, you're going to find that works the best. So you'll print it and fill it out, and then you'll have to take a scan of it. It is 2 pages. So if you don't know how to do that, your phones all are scanners. Send me an email like Kyle did, and just tell me if you have an iPhone. In your iPhone, it's the Notes app. And if you have an Android, depending how new your Android is, your Android also has a scanner on your phone. It does need to be a PDF. And my son is in Dr. Russell's class right now, and he was laughing because he sees the changes in Dr. Russell's syllabus between last term and this term, which is something that's highlighted on mine. It has to be a single document PDF. This is more for those of you with iPhones. I do not have an Apple, and you need to make sure it's in a PDF format, or else I cannot read it. I can't actually convert yours. There's no way. So for all of you, it has to be a single document. And so that's one of the big things we're going to be learning this week. Because in chemistry, we do a lot of math. We do a lot of structure stuff, molecules and things. And so you're going to be doing it by writing. If you don't have a printer, one, you can go to places like FedEx or UPS and print. And so I try to open the next week's folders like Friday or so you have the weekend to print the stuff for the next week. And it does help to be able to write, but you can also just do it on a piece of notebook paper. Just do it so you can follow along. The study sets are due at 6 o'clock. They have to be uploaded onto Blackboard. So your first one will be due Thursday. I will always be here at 5 o'clock from here on out. So from 5 to 6 is an open office hours. The study set, you get 5 points as long as it's turned in by 6 and you've answered every question in the best attempt you can. And then you're going to grade your own study set as I go over it at 6 o'clock. So the first 20 to 30 minutes of class will be me going through the study set. And so you'll want to use, I recommend you get different colored pens because that actually helps. So the study sets are usually just 2 pages or front and back. And then every class, you have a worksheet. And so the worksheets are, instead of quizzes, those you had me for Chem 151, I got rid of the word quiz because the word quiz has that weird connotation. So I called it a worksheet, or WS. And these are usually just 1 page. Sometimes they're 2 pages because I just give you more space. And these are due by midnight. And that is because often as we go through the study set, it will help you to be able to go back and fix some of the questions on here. I absolutely am willing to answer questions about the worksheets, but not during this 2-hour time from 6 to 8. So either the hour before class or the hour after class. I did want to point out something. The first worksheet, so the first study set's due at 6 o'clock on Thursday. The first worksheet is due by midnight. I want to make a comment about the midnight timeline. A lot of things happen on Blackboard at midnight, and it usually becomes overwhelmed. So if yours gets in at 1 or 2 in the morning, I really don't care. I'm not going to mark a point off for it being late because I'm sound asleep. So don't be like freaking out. Oh my gosh, Blackboard's not, it goes slow at midnight because everything's due then. But there is a question on this first worksheet. Those of you who have me for Chem 151, you might remember this. There is a video that is actually was already on our Chem 221 YouTube list. And so it is watching that video. I think it's about 45 minutes. And it's usually tonight, usually we have class for 3 hours. And so I usually spend an hour going through that PowerPoint. So I pre-recorded it. And I just ask that you listen to it and write a paragraph about your thoughts and inspirations that you might have had. And then there's some famous people that I talk about in there, and you just match them. And again, the worksheets are going to be graded. They're 5 points, and there's like 15 of them. I did this last term with my Chem 104, and my son told me I was crazy. I've never had a class do so phenomenal. And so I'm doing it with you guys, that I broke all the study sets into 2 pieces. They're smaller assignments, and you just have to turn one in every class. So it makes you have to keep up with the class. And I would encourage that you just not be shy and come to office hours either before class or after class. Get back to where. All right, I did send a class email on Sunday. I think 7 or 8 people have added since then. And you guys are the best class so far. The half of you responded. And I can't remember who found my typo. Several of you found my typo. And then Damon found something even more interesting, which my mom loved that he couldn't believe I would have a typo and put calcium instead of magnesium. But if every single one of you responds to that email by Thursday, everybody in the class gets a bonus point. So about half of you already have a bonus point, which is awesome. You don't want to be that one person who keeps everybody away from a bonus point. So just answer the email, which is, why did I number instead of 1, 2, 3, 4, 5, 6, 7? Because it's a chemistry class. And we're going to be talking about this tonight, which is 1 to chemists is hydrogen, 2 is helium, lithium, beryllium, and so on. So with that, mention the periodic table. 2 weeks from today, you guys are doing a class presentation. Part of the reason we're doing it that early is your labs are due on Saturday. I have an office hour on Saturday because your labs require often help from your humble teacher. And I am going to be traveling over that weekend. And so by next Tuesday, you're going to have an element picked. And I don't know if somebody from Chem 151 wants to admit to it, but having watched my son do this, pretty much everybody does their paper the day or 2 before anyway, and prepares a presentation. I'm going to be splitting you guys. You're going to self-select into 2 groups. And so the presentations will be probably about 10 people in each group, or actually now 11-ish. And you just do about a 5-minute presentation. And they're really fun. I think they're really fun. I guess it's because I don't have to do all the talking. I don't know if somebody from Chem 151 wants to make a comment about the elements and presentations.
It's not bad at all.
All right, anybody else? Any suggestions? Oh, go ahead.
No, I was just saying, I was like, it was okay. Like, it wasn't bad at all.
It's better than an exam, isn't it?
1,000 times better.
There you go. So that is why. So you're going to actually have 2 presentations in there instead of us having 5 exams. So normally in Chem 221, we have 5 exams. We have 3 midterms and 2 finals. And so I got rid of them and put presentations in. I don't call them exams. I call them celebrations because we're celebrating what you've learned. So this first class presentation is on an element. Again, if you had Chem 151 with me, you do have to pick a different element. And I did post about 2 hours before class. In the syllabus folder is just like a 1-page of what I'm looking for. And it's really not bad. Pick an element that you want to learn something about. And so that's going to be different for everyone. So I'll pick on Kobe for a minute. Kobe's a geology major. So last term he did the obvious one, which was silicon. There's actually a couple other ones that are big in geology. If you're into, obviously, astronomy, you would want to pick one of the ones for astronomy, or you pick something that you've always wanted. Like Damon picked silver because of connection with, I think, with werewolves and stuff. So I don't know. Anyway, have fun with that. So again, study sets and worksheets, pretty much every class except the week when we have a class presentation. That's all you'll be doing. And then, right, the labs. I did post your first lab today. I videotaped myself doing the lab, and then I got home and deleted the video. And so only like a small fragment of the video is there. I did get the data, thankfully. So you pretty much just had to watch the 7-minute video. And there are a lot of calculations. And so as we go through the notes today, I'll talk about that. So do look over the syllabus, and then if you have questions on Thursday or Tuesday. The other question somebody emailed me today, we do have class both Tuesday and Thursday from 6 to 8. And then again, I have office hours before and after. So if you have questions that you want to go over on the study set or worksheet, or you can just come in and I can even put you into rooms to work on stuff together if you decide to do that. Are there any questions for me before we go ahead and get started?
Well, just one question. So you were saying that the study sets and the worksheets are all due every Tuesday and Thursday. So every Tuesday and Thursday, there's the assignments comprises of study sets and worksheets.
Yeah, so if you look at the syllabus, it tells you what's due. So today, of course, nothing's due because they're the first one. So on Thursday, you'll have a study set due. It's 5 points. And a worksheet due, it's 5 points. If it's late, actually, I did want to say is if you do, everybody's going to have a blip day where they just don't get to it. It's 1 point deduction for turning it in late. You have until the celebration to get your stuff in, and you only lose 1 point. So anything from the first 3 weeks has to be in by the 4th week, and then we move on to the next set of stuff. So does that answer, Daniela? It helps students stay on track. You can't get behind, basically.
Understood. Thank you.
Yeah. And it also helps me as a teacher because it requires you to think back over the information from the previous class. And so again, it used to be that these assignments, there were half as many assignments and they were worth twice as much. And so I redistributed the points in this environment, and it worked really well for my one class last term. It was really one of the best classes I've ever had. So I am traditionally a chalkboard lecturer, and I 10 years ago went on a sabbatical and made notes up and then got better with notes. And I wasn't going to reinvent myself when I thought I was going to be secluded like all of us for a month. So there are notes posted. If you did not print them, you can just like write down, realize this is being recorded. And so I will upload to YouTube. It will be there tomorrow. You can always go back and like fast forward to the parts that you missed to fill in. And I will tell you this, my top students last year, when they studied for the celebrations, my one student, I had the first exam, only one student got an A. And he said he went back and rewatched and redid all the notes. And then the next one, there were a whole bunch more A's, and they said, yeah, I started doing that too. So you guys have a huge advantage in this because I've never recorded myself before. So you can go back and do that. For those of you in Chem 151, I want to put out a small warning to you. One, you're going to see a lot of review these first couple weeks, and a lot of things that I created for you, I'm bringing into 221. Don't get over comfortable because there are extra dimensions that we start adding. So yeah, you have a huge advantage because you did this last term. So you got the basics, so you get a chance now to get a better grasp of it. Also for any of you, if you find by the end of this week, you're like, wow, I have had no chemistry, I'm not sure if I can do this. make sure you talk to me because there is a Chem 151 class this term. And so we can definitely switch you into that if you decide. But I've had many top students who've had no chemistry background. I had a gal who was an English major, and she ended up being my top student. And she's a PA now up at OHSU. And she said she wanted to go back and become a PA. And so I was her first class, and she'd never taken science. And she just had really good study skills. All right. So chemistry,
Sorry,
usually,
sorry,
ahead.
I have one question that you probably already answered. So the study set just need to be done by 6 p.m. on Thursday, and the worksheet we can turn it on midnight of that day.
Yes, so the study set doesn't just have to be done, it has to be scanned and uploaded onto Blackboard. So if you are new to this, you want to make sure you might come early so you can make sure you figure out what you're doing.
Okay.
Yeah, but the worksheet is due by midnight. So think of it this way. The worksheets are kind of like a mini quiz, but they're a take-home quiz. And the study set, when we go over the study set, usually helps you if there's some questions you might have had on the worksheet, but I'm absolutely willing to look at your worksheet. The worksheet will sometimes have more challenging questions so that I can push you to the next level. So if you're having trouble with the worksheet, like try it, but then say, okay, I'll wait until after she goes over the study set, and that might help to fill in some of the questions that you might have.
Okay, thank you.
Yeah. And again, you'll kind of all get used to this, like any class in the first week or two. So usually I ask the first class, you know, we're in a chemistry class, so what is chemistry? And get all sorts of answers. But the biggest thing is it is the study of the elements. And that video that I made, I talk about that and where the term comes from, because the original elements, of course, were fire, air, water, well, earth, right? So solid, we walk on solid ground, and water, the fluid or liquids. Air is the gas phase, and fire is what transforms them. The thing that's interesting here, because they always leave it out, because everybody seems afraid to talk about it, is there is a fifth element, and that is ether. And so ether is really the easiest term I can think of in English is it's the vibrations, which is really where everything's at. And so the material world, which I teach, cannot exist without the ether, which is the ethereal world, which would be like the God, the heavens, however you want to talk about it. So chemistry is traditionally taught as the study of matter or the material world, the solid, the atoms that are created from our thoughts, from potential, which is what ether was representing. These I talk about again in the video. These are some of the original symbols. This is from John Dalton. That's the other thing I was going to tell you is your other presentation. So you actually have a second presentation this term, which is not until the 10th week. That one is going to be on a famous chemist that we discussed this term. So it could be somebody from atomic theory. It could be somebody from quantum theory because we do quantum theory. It could be somebody from thermodynamics. It could be Avogadro, which is moles and stuff. But that's later on. All right. The other reason I wanted to do presentations early on was it was a chance for me to get to know each of you a little bit in there. These symbols are much easier to understand, and we'll be talking about the periodic table tonight. So there is one here. I used to, this is a periodic table I used to always give out in class. And well, this is from somebody's exam and they wrote on it and stuff. It is really handy to print a periodic table. In the past, when I had more control, there's something that is missing from this periodic table, and that is the names. And so in the past, they had to learn the names of at least the first 36 elements. I encourage you to become extremely familiar with the names. I actually recommend that you print a periodic table with the names because your classmates are going to. But as we get into this, like we get into naming by the third week, your exams are going to have a time limit to them, that you are going to want to know that like Fe is iron without having to get a magnifying glass and look at the little words on there. Some of my students last term who were really successful, they actually went ahead and got a poster, which you can find on Amazon for a couple bucks, and they put it up on the wall. And so when we were talking in class, they always had it right there. But you are going to want to print out some kind of periodic table that you find online. I'm going to make suggestions over the next 3 weeks of certain things that should be on the periodic table, which we'll get into probably in like 2 weeks and stuff. All right. So I bet I printed on both sides. Yes. We're going to go ahead and jump right into the subatomic realm. So I used to start this class, and that was pretty much all the chemistry I did the first day, and then we just talked about math. And I realized it's chemistry. I wanted to start with some of the fun stuff. So to understand how the periodic table, why the periodic table is arranged like this, we have to understand subatomic particles. And there's actually hundreds of subatomic particles, but there's only 3 that we're going to be talking about in here. The first subatomic particle, does anybody know what was the first one that was discovered? And by whom? This be a bonus point. I offer bonus points randomly, besides in the emails.
Was it, wait, subatomic? Oh, it's fine.
Nobody else? Nobody's watched my video. It was the electron, J.J. Thompson. Sorry, when I write, I sometimes get that. So the negative, so the electron, the negative is its relative charge. It doesn't actually have a -1. When you take physics, you'll talk about coulombs, which is a measurement of charge. It's a unit of charge. And so it has an actual number that they give it. The reason in chemistry we give it a -1 is when J.J. Thompson discovered it in 1897, and everybody laughed at him and said he kept finding these numbers. I talk about some in the video, that every element kept having the same ratio of charge to mass. He didn't actually discover the electron. He proposed that everything must be made up of these pieces inside of them. That once they found the negative, they knew there had to be a positive because there had to be a neutral way, and that would of course be the proton. And so for most of you, this part should be review of things. And so the proton was discovered, I can't actually remember now when, but there is actually one that has no charge, and that is the neutron. And it took them over 30 years to find the neutron because it had no charge. And so it doesn't deviate in an electromagnetic field. The symbols for these are lowercase because these are subatomic. These are the particles that are inside every atom. So the past 100 years have different names, like the technology age and stuff. But before that, we were considered the atomic age because of discovering that atoms could be split and that we could get energy from them, and quantum mechanics and all that kind of stuff, which is what allowed the technology age, was understanding how electrons work and the probability. And when we get to quantum mechanics in the last 2 weeks, I mean, how cool is that you guys are going to get to learn quantum mechanics and thermodynamics and all these big words. One of the other things is the relative mass. So on the video, I talk about their actual masses, which are extremely small. I can't remember what the number is, but we always say that protons are about 1 AMU and neutrons are roughly 1 AMU. And AMU means an atomic mass unit. And it is roughly, just more to get a perspective, 10 to -24 grams. So a gram is about a grain of sand. Actually, that's probably a milligram, but no, it's probably, anyway, 10 to -24. These numbers are numbers I can't even conceive how small these are. We talk about them, people talk about them haphazardly, but this is phenomenal, the size of these. The electron, a mistake that a lot of students learn is the electron has no mass. That's not actually true. It does have a mass, it's just really small. And it's about 1/1820th of an AMU. So it's would be like if these were the size of, say, an elephant, an electron would be the size of a mouse, or a Tyrannosaurus Rex versus a mouse. So this is so much smaller that it's negligible. The proton and the neutron are called the heavy subatomics because they account for virtually all the mass. And virtually means 99.999999999% of the mass. All right, the electrons, they do have a mass, but it is negligible when we figure out the mass of the elements, which we will be getting into next week because we'll be talking about moles. So the other piece of information about subatomic particles is where they are found in the atom. And what they found is that this is actually an experiment that I talk about in the video, and I might talk about briefly here. The heavy subatomics are found in what is called the nucleus. And so J.J. Thompson, who discovered the electron, had this crazy concept that he became like a god in the science world, that, oh my goodness, this guy's a genius. He came up with this idea. Everybody laughed at him for several years. And then we all built off of his theory that, yes, there are these itty bitty, tiny, itty bitty, teensy weensy particles. And so he had this plum pudding model. And Ernest Rutherford did what's known as the gold foil experiment. And he could take a piece of gold foil and pounded it into a micron thin. So that's a micron, 10 to negative 6 meters. It is the width of your hair. And so gold is pretty amazing because you can pound it into a very thin piece. And Ernest Rutherford actually won a Nobel Prize for his study of, this is alpha, his study of alpha particles. And alpha particles have a +2 charge. And they have a mass of 4 AMUs. Now, they did not know what they were made up of yet. They just knew they had a mass and that they had a charge. And what his theory is if he shot these alpha particles at this piece of gold, well, that anytime it came near something with a positive charge, that he was going to see deflections. And based on the deflections, he could then figure out how everything was arranged inside the atom. And so he had a doctorate, so he didn't have to do anything. He had his lackeys do the stuff, and these guys sent thousands of particles. And pretty much, and this experiment still goes on today. They're now at, I don't know, billions and billions, that 99.9999999. I swear, I love having the chalkboard because you get to keep going. I think they're up to 18 nines. Percent went through. Nothing. Did not come near anything. That's a number that can't even fathom. That there was nothing. Now, I love using this word nothing. There's nothing. The atom is empty. In that nothingness, in that emptiness, that's where everything's really happening. But chemistry, we study where the something is, the 0.00001%. Actually, we're studying the emptiness, because the emptiness, the nothing, is where the potential is. That's the ether. That's where the vibes are happening. That's huge field study, which has made everything that we do in this age. But every once in a while, that 0.00001% of the time, they would get deflections, and they would get crazy deflections. And so he came up with his model, right? So he actually went into seclusion for 18 months with this data, how often it went through. He kept sending Geiger and I think it was Chadwick back to keep doing it. And they'd come back like only 1 every 1,000 or something would deflect, and the angle deflection. So this is before calculators and computers. This is 1919. And using a slide rule, he said that all of the positive, before they discovered the protons, all of the positive and mass was concentrated in this tiny itty bitty speck. And so try and think, oh, the analogy is that this speck was the size of a pea. So I think you all know what a pea is, or a chickpea, or a lentil, whatever your favorite one is. It doesn't matter. They're all slightly different sizes. The atom would be the size of an SUV. And so all of this, there's nothing there. There's nothing that has mass. So matter is something that we can measure the mass in. This is though where stuff is happening. The electrons exist outside of the nucleus in this area, but they can only be in certain places. That's when we get into quantum mechanics at the end of the term. That's the idea, and they keep concentrating this more and more. The reason it took Rutherford 18 months to figure it out was not that he is brilliant. He was brilliant. It was, if this is positive and this is negative, we all know positives and negatives attract. So why didn't the electrons crash into the nucleus? And that was Niels Bohr, who said, well, what if it can't? What if the electron is restricted to orbitals? So the electron is in orbitals around the nucleus. So I always talk about this. So our classroom traditionally is right next door, which is quite ironic. It is right next door to the planetarium. So Mount Hood Community College has one of only 4 planetariums where we have the star shows in the state of Oregon. Of course, none of them are open right now. And so we would be right next door, and I would humbly be walking my chemistry class where I'd have my 20 students waiting, and there'd be like 50 students waiting to go into the planetarium. Or they have shows in the public, we get hundreds of people coming. And when students have astronomy class, they're like, I have astronomy, it's so exciting. And I'm pretty sure people don't sit there saying, I have chemistry tonight, I'm so excited, I'm so excited. Damon might be, or some of you might be like, yes, I have chemistry, but you should be, because chemistry, it's not quite the same as the solar system model, but this is happening inside every atom in our body. The emptiness inside an atom, there is more emptiness inside every atom in your being, in your room, in everything, than there is emptiness in outer space. Something to ponder. So you're more likely to run into something if you're floating around in outer space than if you go inside. Go watch Ant-Man. We should all have to watch that movie, right? So when he actually goes inside the subatomic, that's when he's in the ether, when they do that weird like hallucinogenic stuff, because they don't really know how to explain it. Max Planck is the father of quantum mechanics, and he's also the father of the term matrix, which is where they use that term from the movie. But all matter originates and exists only by virtue of a force. That's where George Lucas took the term force from for his famous movies. We must assume behind this force the existence of a conscious and intelligent mind. And this mind is the matrix of all matter. So that's what a lot of stuff is talking about, that we're all really in this illusion of the matrix. All right, so back to the other side, periodic table. I'm putting this with the periodic table. How it works is the atomic number. I did not call it the Z number. That is what it is called in the literature. I don't like these terms of the mass number is the A number and the atomic number is the Z number. I mention that in case you go and do additional reading and stuff, or you go to higher level physics or chemistry classes, or talking with the aliens. So back to, I don't know people's names yet. I also talk about when we talk to the aliens, the periodic table is going to be our translator, because atomic number, hydrogen is always going to be atomic number 1 no matter where you go. And what that means is the number of protons. Any atom that has 1 proton, in English we call hydrogen, and we symbolize with an H. Any atom that has 12 protons is called magnesium. So the typo in that email that some of you, like most of you don't know me yet, and you're all so kind. You're like, I don't know why you went from sodium to calcium, except it fit into your little scheme there. It was because your teacher just did not pull out her periodic table, and I was just typing, and I was thinking calcium came next, and I know it doesn't. But I've kept the typo in there. I remember doing that last year too, because I find my typos amusing. All right, the mass number is the total of your protons plus your neutrons. So something about the mass number. The mass number is not on the periodic table. Let's do this in a different color. So it's not on the periodic table. So looking back at my periodic table, these numbers underneath, those numbers are what is called the average atomic mass. Yeah, so if we like make a little square here, let's just say this is carbon, and carbon is element number 6, and there's this number underneath, the 12.01. That number is the average atomic mass. And I think there's a question on your study set that is not on the notes, and I actually comment that on the study set, and so you can leave that one blank. I'll go over it when I get on the study set. I think it's the last question. That number comes from doing some math calculations. The mass number must be given to you. And so we're going to do a little chart in a moment. The atomic number is on the periodic table, and that is the ID of what element you're dealing with. So if I asked what element has 26 protons, you would just find element 26, and that is Fe. But I'm going to always be asking you to give me the name. So iron has 26 protons, and nickel has 28. Silicon has 14. So the atomic number, this whole number that is given on same on every periodic table, is the number of protons. Just a real quick side note on periodic table. I had a student who's from China one year, this is many years ago, and I used to have a periodic table from a couple different countries, and the symbol, they'll use our symbol, like potassium, calcium, but they'll also have the Chinese symbol. And he told me there was, at the time I was in school with Chinese medicine also, the symbol for qi, or breath of life, life force, was actually part of every symbol for the elements on the periodic table. So they understood this idea of the ether, of what's going on in the space there, that creates every element. All right. So be careful with your words. Your words create your elements in your reality. All right, so we're going to fill in this chart. And again, if you didn't print the notes, just kind of follow along. I remember last term, a lot of people kind of freaked out because they didn't print notes the first day. All right, I apologize. I have to figure out when I'm in Oregon, I had it all set up. And so Ca is the symbol. This number here up above is mass number. And typically down below, we put the atomic number. But since you're always going to have a periodic table in front of you, usually the first day I give out hot pink periodic tables. They're hot pink so you don't lose them. But that's why my periodic tables are always colorful, so I can find them very quickly in all my notes. So I don't have to give you the atomic number because on the periodic table, it is there. The 40 is not this number. This is a whole number. We're going to get to that very shortly. When we're counting subatomic particles have to be a whole number. So the atomic number for Ca is 20. Ca, of course, is calcium. So on your study set and also on your worksheet, you have a chart like this that you get to fill out. Yeah. All right. The mass number, I gave it to you. So it's right there. I'm going to actually jump to the next one also. So S is sulfur. There are two ways that you can be given the mass number. One is this format, where it's written as a superscript before, or where it's written as a -35. And so the 35 means it is mass number of 35. The atomic number is sulfur. So looking again at our periodic table, sulfur is number 16. And this is why you're going to want to have one always in front of you. So that's kind of, if not by Thursday. Thursday, we're going to be doing a lot of math, but definitely by next week. So you can kind of scroll around online and find one that you like. All right, the protons and the atomic number are always going to be the same answer, period. That is what tells you what element it is. That never changes. So how do I find the neutrons? So much more fun.
Subtract the protons from the mass number.
Yeah, so the protons and the neutrons equal the mass number. So if we take the mass number, you don't have to write this, subtract the protons, we'll get our neutrons. So on this one, the 40 minus 20, we're at 20, or 35 minus 16 is 19. Now, I picked that 35 for sulfur for a reason. To point out again, this 32 is not the mass number. This 32 is what's called the average atomic mass. And average means we're averaging a bunch of numbers together. And that is, we're going to go backwards a step. There was a word up here that I didn't talk about. Usually I have these big chalkboards, and so I can write all over the place, and you guys have notes that you're trying to fit it on. So now I'm seeing where I was looking for another color. So an isotope means that you have the same element, but they have a different mass. So there are other sulfurs. And when we add up all the different sulfurs, we'll get 32.07. This question on this chart is specifically asking about sulfur 35. Sulfur 35 is not a very stable sulfur. I actually worked with it. My degree is actually biochemistry. And so for labeling DNA, we used sulfur, or labeling cells, and phosphorus that was radioactive. So the number on the periodic table, the mass, the average, is always closest to the most stable form. So sulfur 32 is going to be the most stable. And as it deviates off more, it becomes less and less stable. Anyway, but it does exist, and that's when they become radioactive, and we can do interesting things with them. All right, for this page, the electrons are going to equal the protons unless there's a charge. And we're going to study ions in 2 weeks. And so we'll worry about that then, or it might show up on the next page. So for right now, my protons are my electrons. So we get kind of the basics. All right, so the next one, we're going to reverse this. I start with the protons. So if I have 17 protons, my atomic number is 17, my electrons is 17, and element 17, Spencer's did a wonderful talk on chlorine last term. And so it is Cl, and Cl is chlorine. And when I ask for the symbol, you can just write Cl. If I ask, I think on this first study set, I say, show the symbol with the mass number. So the mass number would be the sum of these two. So the 17 plus 20, so 37. So you can write it like we did with the calcium. Again, you're not writing this number on the periodic table, the chlorine, because that number is the average of all the isotopes. So chlorine, yeah, there's a question on the next page about that. Let's just finish this. All right, so number 79, gold. It's so wonderful, and I have big charts behind me in the classroom. So 79 is gold. Rm is gold. And so in the English language, that's what we call it. And The 79 would be our protons, our electrons, and we would subtract and we would get what, 118. Yeah. All right, and then one more. So to figure out this one, this is not element 17. This is the neutrons. I would have to subtract the 70. I don't know what I just said. I would subtract the 70 from the 120. And it is going to be element 50. 50 is SN. SN is for Sanus, is the Latin name. So the elements that are have been extremely useful for the longest time have their Latin names. So calcium and natrium, aurum, argentium. So Sanus is tin. I had a student sit in the front row, and she would always say tin is a sin. And so that some of these silly acronyms work really, or not little sayings. So tin is a sin. So tin is SN, as opposed to TI. TI is, and they all said titanium. Yeah. You all knew that. All right. So I have it on this page, so we'll talk about it here. On the periodic table, there are our periodic table, let's say periods. Let's do it this way. Periods are going across horizontally and families are going down vertically. So Dmitry Mendeleev organized the periodic table based on their reactivity. They are in these family, they reacted in a specific way. And so he created families. I know in the slideshow, I show a picture of his original periodic table, which does not look like this, but he came up with this idea of families. He was not the only one. There were other people who did, but his paper was the best one. And so we give him credit, and he's gone down in history. The first family is called the alkali metals. And the second family, going down, is called the earth metals. Some places give them their full name, so I'm going to put it in parentheses. They often call them the alkali or alkaline. Don't worry about the difference in that, but alkaline earth metals. They're called the earth metals because if you were to study the earth and the elements in the earth, most common elements besides silicon and oxygen are these guys, as well as some other ones that were originally in that family in Dmitry Mendeleev's periodic table, like iron is extremely common in the Earth's crust. So these are really common in the Earth's crust. They're found in lots of minerals and stuff. So like beryllium is found, I think, in rubies. I can't remember. A lot of geology students will often do beryllium as their element because it's found in a lot of the elements. My question was going to be, does anybody know what the word alkali means? Because both of these terms got that in front of them. And it's actually true for all the metals. But the 1As and 2As are said to be alkaline. Does anybody know what that word?
To do with their pH.
Yeah, so these guys, when you they make our common bases. So sodium hydroxide, lithium hydroxide, calcium hydroxide, magnesium hydroxide. So in water, they tend to have a high pH. And we just barely will talk about pH for just a little bit this term. In 223, half of the class is about acids and bases. All right, the middle part of the periodic table, so where it drops down, they often call those the transition elements. On the periodic table, the first two families and the last two families are names that you're going to hear me respond to. So for right now, we're just going to look at those names. So I'm going to jump all the way over to the last two, which are 17 and 18 is how they've renumbered them now. So we should have done this on this side. Keep forgetting I have this periodic table here. So this is the alkali metals. I'm going to just flip over. This is the earth metals. And over here, 17 is called the halogens. And 18 is special. They are the noble gases. They are perfect. They are unreactive. As opposed to the halogens that are extremely reactive. Everything on the periodic table, we'll talk about this in 2 weeks, everything is reacting to become like a noble gas. The noble gases were not part of Dmitry Mendeleev's periodic table because they didn't react, so nobody knew about them yet. And so until the technology was there, where they had the spectroscopes and they started looking at atomic spectrums, did they discover elements that they didn't even know about? And that's because they're not reactive. They're not found in chemical compounds. All right. The middle part here that dips down, and again, we get into quantum mechanics, we'll look more at some of the details of how the periodic table is arranged. They're often called the transition elements, or I often call them the transition metals, because they are all metals. And so that was the other thing I had on that other side of the paper. And if you didn't print, you can just like make a sketch of the periodic table or just make notes. There is, and that's a problem with my mom's printers in black and white. So many of you may have gotten this in color, is there is a staircase that comes down through here. And this staircase separates the periodic table. Oh, this is pretty cool. I didn't realize. That's why I got this one, because there's actually more new elements, and all of these have names now. So this periodic table is the previous election. So election day 4 years ago was actually when they officially named this whole row on the periodic table. Again, periods are going across, and so they just call this period 1, 2, 3, 4, 5, 6, 7. They're actually now into the 8th period on the periodic table. If you watch Star Trek, they've gotten up to like 300 elements, which is pretty bizarre. But yeah. So my question is, does anybody know what the staircase separates on the periodic table? And why I took that moment to draw it in?
It separates metals and non-metals.
You got it, Maddie. And actually, do you remember, I'll give you the bonus point, what it is if they're touching the line?
It's a metalloid.
Yeah. So on this side of the staircase are the metals. On the left side, anything below the staircase is called a metal. And you guys all know what metals are, like iron, silver, and gold. Right? So they're lustrous. We make jewelry into it. We can pound it. We can draw it into a wire, and it conducts heat and electricity a little bit too well. On this side are the non-metals. These can be different states of matter. Some are solid, some are liquid, some are gases. So over here, and then the ones that are touching the line. So boron, silicon, arsenic. So they have to be touching the staircase on 2 sides, tellurium, and they can be above or below polonium. So aluminum, there is a problem with this periodic table. It's not perfect, like your teacher. Aluminum, unfortunately, looks like it's a metalloid. Aluminum is a true metal. These guys, the ones that I circled, are called, traditionally they're called metalloids or metalloids, depending on who your teacher is. I've heard them said both ways. I don't really care. They are now more commonly called semi-metals, and that is because they are semiconductors. So these guys conduct electricity, but they don't conduct the heat. So it's what's in your cell phone, it's what's in your pad or computer, and so it's not heating it up. Aluminum conducts heat terribly well, and so your computer would not work so well there. AT, by the way, sorry, I did not, there we go. I did not circle it. I think it is because they've never been able to classify it. So if you're into comic books, there is a guy who did the whole periodic table of comic books, and a lot of these show up in the comic books. Of course, Krypton and Kryptonite, there's a connection there, but astatine apparently is so reactive. They've never been able to study it, and it burns out your eyes, which is another problem. You're not going to be able to study it. So I don't know anything really about it, so I wouldn't ask about it. Polonium in some periodic tables will say it's a metalloid and some do not, and that's because its half-life, it's only around for like 6 microseconds. And so how can you study something that's not even, like, it takes you, I forget, a millisecond to snap your fingers. So this is 1,000th of that. Like before you even have the thought has processed that you want to snap your fingers, polonium's gone. So you can't really study something like that. All right, so that's just a quick look at the periodic table. They, again, Mendeleev arranged them based on their families, like a card game of hearts. That's the story I tell in there that everybody tells. So like hearts, spades, clubs, and diamonds. So he put them into these families, and they're in families. The families have similar properties. Oops, sorry. So they have similar chemical reactivity. So this is going to be a question that is on your worksheet and your study set, and I think on the next page. And that is, if I asked you what element is most like fluorine? So you would have to get, this is where if you start learning the names of your elements, the first 36, just get the names so you don't have to remember the order unless you're really bored. But that way you just look at it and go, there's fluorine, and you don't have to try and find the names because that is really tedious and takes time. If I asked you what element is most like it, you would pick something that is in the family. So fluorine, chlorine, bromine, iodine, if you want, you pick astatine. So not next door, it's up and down vertically. All right, so I get these wonderful powers as being the host of this meeting. Something I didn't mention, that part of your grade is attending class on Tuesday and Thursday. And it is attending for the whole 2 hours. I do ask questions where you can get a bonus point. So I have to mention, and like if you all answer that email, everybody gets a bonus point. But it's like the only control I have. And so if you leave early, you lose a point. If you don't come at all, you lose 2 points, but you can make it back up. If something's going on, you come to an office hour, that can make up one of the points that you might have missed from attendance and stuff. So just try to stay. If you get kicked out because of Wi-Fi, just try to sign back in. I know that everybody's Wi-Fi does funky stuff. And you're in black boxes. I don't even know if you're there or not. All right. So what we're going to do is this next page is practice. Oh, and that wonderful thing is Zoom takes attendance for me. So I'm going to stop recording for 5 minutes. So you have a choice. You can take a 5-minute break, or you can try and work on this page for 5 minutes. You can just do the box. You can try some of these questions, and then we're going to go over it. And then we're going to look at the metric system. All right. So if you want, you take a 5-minute break. I'm going to pause Zoom. All right, so let's go ahead and walk through this page. And again, if you're able to print notes, which you can, it's just figuring out how to do that. It does make a difference. Yeah. All right. Oh, I said this question was there. Premonition. because I wrote the notes. So chlorine has 2 stable isotopes. It has many isotopes, but these 2 really are the only 2 that are significantly abundant. Now, if you had a 35 and a 37, and you took those numbers and you averaged them, you should get an average of 36. But when we look on the periodic table, my average is actually 35.45. So again, this number below is the average atomic mass based on the isotopes percent abundance. So this number is the average atomic mass, and it comes based on the percent abundance. And again, I'm pretty sure there is a question on your study set where we actually walk through how they derive that. I'm not going to go through that tonight. So when you get to that question on your study set, you can just leave it because I know I'm going to talk about it then. So if they were equally abundant, it should come out at 36. But since it must have much more of chlorine 35 because it's weighted towards the 35. There's actually a mathematical way you can figure it out. So the more common one is the Cl35 because the average is always closest to the more abundant. So then I asked how many neutrons are in that one. Well, we have to look. Chlorine's number 17, which means it's 17 protons. So we would take the 35, which is again the mass number. You don't have to write this down. This is just my best way of clarifying. Minus the 17, which is the protons, and that will give us 18 neutrons. I don't need to see that math. I'm just looking for the number 18. Any questions with that? Because hopefully this is usually the part that students go, yes, I can do this. Chemistry is great. Everything about the class, you're going to say that. So 4th period, I recommend numbering your periodic table down 1, 2, 3, 4. And so we're in the 4th row. Periods are often called rows also. And the earth metals are in the 2nd column. So 4th period earth metal is calcium. So the name and the symbol, calcium Ca. So if this was like a worksheet question, I would want both of those answers. Right. All right. There are 2 alternative ways for, there's actually more than 2, of numbering the families. Historically, they numbered them as the A's, and then these in the middle were the B's. And now they've reverted. Most of them are just numbered 1 through 18 straight across. There are these 2 down here that would fit in right there between 57 to 72. They just moved them down here because otherwise the periodic table ends up really elongated. There's some really fun periodic tables online. So we have to find 4B and the 4th period, and that is Ti or titanium. So this is also hopefully helping you to learn some of your names and symbols. Similar to sodium. So sodium is Na, and so we would just find something around it. So you pick lithium, you could pick potassium. I'm going to go with lithium. And I want to mention something because I'm seeing it right in front of me, which is hydrogen is not a metal. Hydrogen is a non-metal. It is a gas. They put it here, as we'll see over the next couple of weeks why they put it here. But on some of the periodic tables, it actually sits above the periodic table. It doesn't really belong to any families because it's in a family all of its own. All right. Halogen are over here. Somebody nicely labeled it for me. And the 5th period, halogen would be I, which is iodine. All right, alkali metal in the 3rd is sodium. So Na or a natrium, but we're going to go with the English name of sodium. What family is unreactive? Does anybody remember that one?
8.
Yeah, the 8 or the 18, which is the noble gases. I sometimes spell it Nobel by mistake, so that's just ignore your teacher. I probably did that earlier. And then the third period, metalloid. Aluminum is not, or aluminum. Si, silicon. So, yeah. All right. Which is in like any quartz-based crystal, and quartz-based crystals are huge on our Earth, and they're also the basis of all our computers and stuff. They have magical powers. That's why your computers have magical powers. All right, so Na is sodium. Recommend, going back and doing this page again on your own and seeing how you did, how much you got. All right, sodium is number 11. And the mass number, this has to be given to you. It has to be a whole number. Everything in this table has to be whole numbers. So again, these numbers are averages from different isotopes. This question's asking a specific isotope. All right, the protons are the atomic number. The electrons are the same unless I change them. All right, which I do down at the bottom. And my neutrons are 12. So we just subtract the protons to get our neutrons. All right, P is phosphorus, which somebody just picked as their element. And it is number 35. So that number 35 is our mass number. Looking at our table, phosphorus is number 15. And so 15 goes here and here for protons and electrons. And neutrons are 20. So this is really the big, this is actually something that fascinates me. My students have really liked these like little tables to fill in. So there was this psychological study where they put kids on a playground and they put a clear fence around them. And it was in a really bad neighborhood, and the kids just played all over the playground because they had a clear boundary. And then they put them in this really fancy dancy neighborhood, but they didn't have any fence, and the kids only played like around the slide. They wouldn't like venture out, even though it was a very safe, very clean neighborhood. And so apparently we like having very clear boxes. All right, so this one, I tell you the protons, so it's 33. And 33 is AS. And anybody know?
Arsenic.
Arsenic.
Nobody picked that one yet. Nobody picked that one last term, actually. That's might be a good sign. So number 74. And again, you can show the full symbol if you want. You don't have to. The full symbol would show the 74 up above and actually the 33 down below. But I'm okay with you just writing the AS. All right, for this one, we have to subtract the 24. That gives us our protons. That gives us our electrons. That tells us our element, which is Ti again. So titanium. Nobody picked titanium yet. There's some, one of the things I would encourage, it's also fun to pick elements that are more obscure. Although there are some that I might look at you like, I don't know anything about them. That might be why it's fun. All right, on this one, I did the 47 tells us it's element 47, which Damon should know this one. So Ag is argentium or
Silver.
silver. Yeah, he did an awesome paper. And the parameters on the paper say 3 pages. Like Damon was really into it, and he gave me, I think, a 5-page paper. And so you can go a little bit over that, but writing a 20-page paper doesn't mean it's an automatic A. And so I'm not like, it needs to be at least 3 solid pages. All right. So the mass number is the total of these two, the 47 and 60, so 107. But there's an extra piece on this one. And that is, we lost an electron. So don't gain or lose electrons unless I gain or lose for you. But my protons and electrons were not equal. We get to this in 2 weeks, and then you'll be able to do this. When you lose an electron, you end up with a positive charge. So it is actually an ion. So positive ion loses an electron. My next one, it's element 35 because my atomic number has to be the same as my protons. And in this case, I gained an electron. So you can gain and lose electrons. And when you do that, you end up with a charge. So number 35 is Br, which is bromine. And if you gain an electron, you're going to end up with a negative charge. So when we show charges, it's always shown after the element as a superscript. So a positive means you lose the negative, meaning you have more positive, and negative charge means you have an extra negative. We just have to subtract to get what our 44. All right. So, yeah, I think this is a question. This came from our study set last term, and I think it's on the study set again for Thursday. So for those you had Chem 151, these first few weeks, these study sets and stuff should be a really good solid review for you. And again, if you haven't, you're going to catch up, just put the time in. And that's why I will have office hours before and after class. So don't be shy. All right, so these guys have the same mass number. And so what that means is they have the same, it's a term I forgot to say on the other page, they have what's called the same nucleons. So anybody want to take a gander at what that might mean? Maybe not.
At what? At what? The same mass and same nucleon?
Well, yeah, what does the term nucleon mean? Because I didn't talk about that word yet.
Protons and neutrons.
Yeah, and so why am I calling them nucleons, I guess, is what I was
Because
asking.
together they're the atomic mass number?
They are the mass. So why are we calling them nucleons, though?
They're in the nucleus.
They are the ones that are in the nucleus. So that's back to that previous page, that this heavy subatomic particles that determine the mass are found in the nucleus. And so together we call them the nucleons. And so that word nucleons means the particles in the nucleus. All right, for the next one, argon and potassium, they don't have the same nucleons. So nucleons is our protons plus neutrons. So we want to fill in that lower number. So argon is number 18. Again, I'm just getting that from the periodic table. And potassium is number 19. So if you take the mass number and you subtract the atomic number, you will get just the neutrons, which gives me 22 and 20. So it's not the neutrons. If you do something where you add them, so if we take the mass number plus the atomic number, you will get the total subatomic particles. And what that means, and where that's coming from, is the mass number is the protons plus the neutrons. That's what we just talked about. The atomic number is the protons, but if there's no charge, it's also the electrons. And so we get the protons, neutrons, and the electrons. So the total subatomic means we have all three of them. And so if we add these two together, they both come out as a 58. And so they would have the same total subatomic first one was the same number of nucleons. And then the last one is they are both carbons. They have the same, we would normally say protons, but that wasn't actually a choice here. So they would have the same electrons. There's no charge on them. We will get to ions in the next 2 weeks, so we'll look at that more. Questions? And again, this is what your study set and your worksheet is, what we just went over. All right, so we're going to keep going. I have this side. A couple things I want to talk about. I'm going to come back to page 4 because I'm going to hopefully do that today, maybe. Page 5 is about significant figures or significant digits is what I call them. Actually, already recorded this page like 6 months ago, and in an effort that I could fit all this time into my I usually have 5 hours for this class. So it's actually on there. It goes with this page and it talks about significant figures. It actually then is in study set 2, which is for next Tuesday. However, the lab that you're doing for Saturday, significant figures is actually important in that lab. So it's a density lab. It's measurements that I've already taken in the lab, and then you're going to do some analysis with that. So it's about a 30-minute video, and so I would encourage you, you would definitely want to watch it before Saturday and walk through this page. Page 7 is about density, and it is also a pre-recorded page. And so it's again Tinkerbell teaching you how to work with density. And it goes with this page of your notes. And I think the link is there. It's also on there, that YouTube page. The link to the YouTube is on the Blackboard page. And again, several of you signed up today. It's on the syllabus too, but if you wanted to like look at it tonight, just stay after or email me. Send me an email and I'll check my email when I get out of class after all of you. And I can send you the link, or you just wait until tomorrow and you should be able to access the Blackboard. All right, sorry, I'm just trying to decide which one I want to do. And I'm going to do both pages. We got a half hour. All right, I'm going to start on page, I'm going to look at page 6 and yeah. So in chemistry, we do math a very specific way. This is building up. For next week, we're going to do math with the periodic table. So we're going to be doing moles. So for those of you in Chem 151, you're like, oh, this is great review. I don't know if you've realized in the first 2 weeks, we're going to cover what we did in 6 weeks in Chem 151. So Chem 151 takes everything at a little bit slower pace. But we're going to be working with unit conversions today and again, on Thursday. So Thursday, first half hour, I will go through the study set, which is about the subatomic particles. And I'll be here before class if you have questions or if you want me to look at your worksheet. On Wednesday, I'm in class for like 8 hours. And so the first 2 days, 3 days of class, I try to keep track of my emails. But on Wednesday, I'm in class with my other classes those days. The other thing I want to mention, your labs are due on Saturday at midnight. It is Saturday. If we get done early on Thursday, you might want to start looking at that lab so you can ask questions on Thursday. I do have an office hour on Saturday morning from 10 to 11. I can stay later if people have questions and you're there. And so some students last term actually loved the Saturday morning office hours, especially this rainy time of the year. And they just worked on their lab during that time. And so I will be there always. I'll have this open from 10 to 11. If like you oversleep and you show up at 11, just sign in. And if I'm not there, or send me an email and say, hey, are you available? I'm sorry, I overslept. And if I am around, I'll respond and reopen the Zoom link. Or you can send me what your questions are on the lab. This share screen feature is actually wonderful because you guys can share your screen too. And so Christian was actually really great at this last term, and he did phenomenal in the class. And several other people did too, is that he would come and you're gonna all learn how to take pictures of your stuff in a PDF, and then you can share your screen and have me in the Zoom look at the work that you've done. And so I can give you feedback and say, yes, you're setting this up correctly. So the lab is actually not a difficult lab. It's a lot of adding and subtracting and doing density. And we'll talk about a little bit more on Thursday. What I wanted to show you, though, is how we're going to be doing math with the periodic table. So before getting to the periodic table, we're going to work with it with conversions that may or may not be more familiar with. So it's a way of converting between units, which is why it's called unit conversions. And why we should learn this, it's how chemists do math with the periodic table. So in Chem 221, we use this format of math. Your celebrations, again, I don't call them exams because that causes anxiety. We call them celebrations. It's a chance for you to celebrate and show me everything you know how to do. They are going to be show your work. I'm not a fan of Blackboard. I'm not a fan of multiple choice. I was extremely damaged by my class this summer and some of the things that happened on Blackboard. So you're going to be doing show your work, and you're going to have to show it in this format. And so you're going to want to learn it, and you're all going to be able to. This is not on the study set for Thursday. This is on next Tuesday's study set. Which will be in the week 2 folder. And I open those folders usually on Friday. So you'll be able to start working on that. So just worry about this week, and then you can start on the next stuff. It is actually very handy for even things beyond chemistry. What it means is we're only going to use one equal sign. We're not going to break things into steps. We're not going to say, like, we're going to do this gnome one. We're not going to say, well, I can change grams to pounds. This is how many pounds he weighs. And then, okay, now I can change pounds to ounces. This is how many ounces. We're going to do it in one flow. And all right. Again, because I lose a lot of my powers in this little Zoom format, I have to have certain restrictions, which is that these conversions are conversions between US and metric units. So metric units are grams, centimeters, kilometers, and liters, and imperial units, because we were an imperial colony, are pounds, inches, miles, and quarts that nobody uses anymore, except when we're doing this introductory way. You have to use my conversions. Google has all sorts of wonderful conversions. You will lose points if you use other conversions. So anyway, we'll work with it. So this is the piece of information we have. It's 307.65 grams. And what we want to know about this gnome is how much does he weigh in ounces, so OZ. So piece of information we have to start with, this is where we're going. And I'm going to show you 2 different ways to do it. I'll show you on this one. The math department comes and tells me I have to teach it correctly, so I'll humor them for the first one. Is we're going to make these fractions. And I'm putting them in parentheses because parentheses mean we're multiplying by this fraction. And what we're going to do is we're going to change grams to pounds within this fraction. So up here, I'm just going to talk about it for a moment, that we all know that there's 12 inches to 1 foot. So what a conversion factor is when you write it as a fraction. So 12 over 1 is not the same as 1 over 12, unless we put the units with it, because 12 inches to 1 foot is equal to 1, and 1 foot over 12 inches is also equal to 1. So you can flip conversion factors and they still hold true. So this piece here is just really, it's all based on the units. Sorry, the flow is so different for me in this format. So what you want to do is you want to take the unit. It's why it's called unit conversions. It's all about the units. And you pull the unit down to the lower dimension. Not the number, just the unit. And now we're going to convert the unit to pounds. I write my L in a funky cursive way so that you don't think it's a 1. And now I plug in the numbers. So I know that there's 1 pound and 453.6 grams. So what happens here is my unit cancels. So if a number is on top and the bottom, right, they would cancel out in when you're doing math problems. It's just in chemistry, numbers have both a number and a unit always. A number without a unit doesn't really mean much. All right, and then my next step is I take this unit of pounds, I pull it down here, and I'm going to change it to ounces. So pretty straightforward. So there are, I gave you the hint there, 16 ounces to 1 pound. Now, one of the things with these fractions, these unit conversions, it is the unit that determines what's on top and what's on the bottom, but each piece holds true by itself. So the pounds cancels, I'm at ounces. Punching it in your calculator, sorry, I have a calculator somewhere, but maybe not. There it is. Yeah, you need a calculator of some sort. Your calculator does need an exponent key on it because we're going to be using Avogadro's number, which is outrageously huge. How I punch this in my calculator, again, you don't need to write this out, but I do it all in one flow. So we only have an equal sign once or an approximate sign. So I take my first number, 307.65, multiplying or dividing by 1, it's not going to make a difference. So I ignore the 1. If the number is in the denominator, I just say divide by that number. If the number is in the numerator, I multiply by that number, and then I hit enter, and I get a number. I just mentioned that there's many different ways you can punch this in your calculator. There is going to be one answer. This is extremely effective. You don't have to get all those parentheses. You don't get lost in it. And so I just mention it because there's always maybe 1 or 2 students who go, oh, I really like how you do that. And there's a lot of students who don't. All right. So we punch it in our calculator and we get, our calculator gives us this number, 10.85185, 185, and it keeps going. So the number, oh, that's nice. I see my calculator. The number your calculator gives you is correct, but our answer has to have 3 parts to it. It has to have the number, which our calculator gave us. It has to have the unit, and it has to have the correct Sig Figs, which is that video from Tinkerbell. So just a real quick note about Sig Figs is Sig Figs are going to limit you based on how many numbers each of the pieces of information that you used have. There are what are called exact and inexact numbers. So our answer right now, I'm going to switch to the other page because I have a place to talk about it on the other page. We're going to have 4 Sig Figs. And again, you're going to want to watch Tinkerbell at least by Saturday or by next Tuesday. So that would mean just 4 digits. So significant figures or significant digits, I don't care what you call it. So we'd say 10.85. And that would be our final answer. And that's the idea of how you're going to see me doing math on Thursday and for next like 10 minutes of this class. I'm going to go back a page now. And you can read that this was actually a true story. I got tired. Decided to write about gnomes and fairies about 10 years ago. I don't know why. And this is actually this little gnome that they sent to all these labs around the planet to show that the Earth is not, one, it's not flat, and two, it is not actually a perfect sphere, because we do have different masses in different places, depending if you're at the equator or the poles. All right. So we can go back to the metric page. And actually, yeah, let's go ahead and go through metric here. Scientists, engineers, medical workers, everybody, actually business world, everybody uses the metric system now. Metric system is so amazing because it works with prefixes. And so I want to go through how to use this chart. And we'll do some of these problems today, and we'll finish them up on Thursday. There is right here, and in this chart, they're saying it's a meter, but it could also be a gram. So G is for gram. It could also be L, capital L for liter. It could be a second, it could be a calorie, it could be a mole. So moles are chemistry units. And so this is our base unit, and these are when we get smaller, and these are when we get larger. And so what it is that whenever you have one of the prefix, you have 10 to the power of the base unit. So that's here starting at 0. And the reason we're doing this is we're going to have to do this in that factor label unit conversion format that I just was showing you. Is we're going to have to take the metric and do it as conversion factors. So what that means is if we were talking about a millimeter, 1 millimeter is 10 to the negative third meters. Now, most of us learned about millimeters actually back in kindergarten or preschool. And when you're in kindergarten or preschool, you actually don't understand this concept of negatives or numbers less than 1. You're like learning how to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you learn it as 1,000 millimeters in 1 meter, which is the exact same thing. It's just we're looking at it from a different perspective. These mean the exact same thing, but this is how this chart works. For consistency in this class, I'm going to go with the chart. This chart is not complete. You can actually go online and it keeps going in each direction. You will sometimes see me throw in other prefixes. So you might have to use Google to find what they mean. But these are actually really common ones. The large ones you actually all know, and they change by 1,000. So kilo, like a kilogram or a kilometer. Mega, so if you're thinking about computers and computer bytes, right? So mega, giga, tera, like now we're all getting tera storage, so terabyte storage. And then when they're getting smaller, they have a negative exponent. So decicenti, milli, and then it moves by 1,000. Micro is a millionth of a meter. Nano means 9, pico. All right, so how we can do the math to get practice with unit conversions and the metric. There are other ways to do this, but we're practicing the unit conversions right now. Is we're starting with 65 centimeters. And what we're going to do is we're going to change centimeters to meters. So I take my starting unit and I pull it down here, switch it to the base unit. And then what I do is I take the base unit and I go to this unit. All right, I have to comment real quick on this unit. This is micro. Depending on the printer you use, some printers can't print the symbol. I don't know why. My mom's printer could. And so it will put a little box. And so if you ever see that little box, it's going to be micro. It's a mu. It's a Greek M sign. You want to make sure that it looks like that because you don't want to kill somebody, because that M means milli and it's 1,000-fold different from micro. All right. How this works then is the prefix, the centi and the micro get the 1. And then if we look what centi means, it means 10 to the negative 2. And what micro means is 10 to negative 6. So we end up with 6.5 times 10 to the 5th. All right, let's make a couple comments here. Scientific notation. When you get a really large number, like this number would be 650,000, when you're getting that many zeros, when you start getting like more than 3 zeros, you want to change it to scientific notation. The purpose of scientific notation is it makes it easier to see the number without having to say, do I have the right number of zeros? Same with getting really small numbers. When you start getting more than 3 zeros, you want to be in scientific notation. I also set up here that we're practicing using scientific notation. Now, I want to show you another way to do this one, just to acknowledge that. What I have found, having taught this for a long time, is 2 things happen with metric. One is about half of you never could do metric. And it is because of you never learned it by the definitions. This is actually how it is defined. Milli does mean 1,000th of a meter. And so this gives a consistency of doing it that way. So if you're somebody who's always struggled with the metric system, this chart is amazing, and using it with this, and we'll go through practicing. And then there's half of you who are like, I've never had problems with the metric system. I don't understand why you're doing centimeter like that. So if you want, because we're also practicing learning how to use this factor label format, you can say that there's 100 centimeters in a meter. That's perfectly fine. What has to happen in the next week is you have to find a way that the metric system is going to work for you in your own mind, so you become efficient at it. Because again, that's one of the big take-home things in this chemistry class. I know a couple of you like are even going to nursing school. It's actually one of the first like test or skills things you have to show is that you can do unit conversions, because you actually do it in dosing and stuff. And so I'll often get letters back from students in nursing school, and they're like, oh my God, the first ones, everybody else was struggling. And after your class, I was like, had no fear of it. All right, we take this unit, we pull it down here. And so it's just some people have learned the metric system different than this chart. So I'm just showing you 2 different ways. Do your way and be consistent. You just have to show it in factor label. That some people say, well, micro, there's 1 million micrometers in a meter. You come out with the same answer. You're going to see me using the chart, but I'm just trying to comment that I'm aware of it. All right, we're going to do one more here, which is this one. So 430 milliliters, and I'm going to show you how I'm going to do factor label, which is I have the milli, and it was actually some students taught me this, and you're going to see me use this from here on out. Rather than using parentheses, we call it the railroad tracks, and so you can only have 1 unit in each level of your railroad track. So the millis here, and in my next box it comes down here, and I go to the base. Then I go from the base to the final one. My first one is blank. You can, I learned this after many years of teaching. I had a class finally that told me they didn't like when I left things blank like that. And so you can draw a football, you can draw a snowman, you draw whatever you want. All right, using the chart up here, again, the prefix, the milli, the kilo gets the 1. There's already the M or the K there, so they just get a 1. The definition, which is what these are, the definition goes with the base unit. So milli is 1,000th of a liter. Kilo is 1,000 liters. Put that in your calculator, you would get 4.3 times 10 to negative 4. So negative means we're getting a number that's really small, 0.00043. All right. Sorry, I'm trying to think what my other question was. All right, let's go back to the gnome page. We'll come back if you want. You can try these. We'll come back and finish them on Thursday. Yeah, if you have time, watch Sig Figs. Definitely before next Tuesday because it's on the study set. And the density video. I go into more of the factor label in this, and we'll finish those other pages on Thursday. So I'm gonna stop now, but it's endless.